So, we should be live. Mic's up top. And mic's up top because basically, otherwise it's going to be on top of my keyboard the whole time. So we're not doing that. Yeah. Okay, cool. So I'm going to just assume everything's working and we'll just tuck straight into it. Right. So it was probably Reese here from Stoic, by the way, in case you didn't know. Been a while, definitely. But basically, the other day, I came across this repo that the CF had pushed out, Cardano Foundation, and it was about this is Cardano-Template and ecosystem monitoring. And basically, I came across it because I saw a video, and that video was the CF guys, Fabian and Bora, I believe, basically going through some results because there was a competition or an event or something for people to submit solutions to these kind of use cases, basically. Wait, let me just do something with this. Can we just put it over there? Yeah, that's better. Okay. Right. So yeah, so that was kind of it, really. So I found this. I came across this video where they were looking at some of these things, and so I was like, cool, let's have a little look. So I had a look through them. Some of them are nice. Some of them I'd probably deal with slightly differently. And so I thought I'm basically going to contribute a bunch of, a solution for everything, more or less. And so I thought I'd just do that live, and we can kind of have a look at the process and talk about it. And it all kind of started really because I was chatting with the, I was doing some stuff for the work guys, work courses. And so yeah, so I was basically, I was kind of thinking about videos anyway. So I'm rusty. I haven't done videos in a very long time. Don't expect much from this. It's going to be very chill. It's like 11 something. It's very late. It's very late over here. 20 past 11. So I'll probably do, I'll do one of these today. But basically we saw this. There's a ton of different things. I think it's 21 or 23 or something. It probably says 21 most common blockchain use cases. And it's from a different project called Rosetta. So Rosetta smart contracts. And there are some Aiken smart contracts in here that someone had done a year or two ago, 2 years ago, I think. So they're kind of a little bit outdated. They're kind of old versions. And so they're like old versions of the smart contracts. And so it isn't really up to date, and some of the solutions are a little bit strange. Like, there are obviously differences and limitations comparatively, right? There's differences between EVM or Solidity smart contracts in general and how they worked on Cardano, because the model, the whole way that assets, transactions, everything's managed is in a different way, right? It's a different model. We've got the account model for EVM, like Solidity, and we've got the UTXO model for Cardano. And so because of that, literally the way the blockchain functions is different. So there are huge differences in how these tools work. And I'm going to try and actually pull this up. And so basically, what we want to do is we're going to grab some of these, we're going to have a look at them, and we're going to probably only do one today, because it's going to take a bit of time, right? And obviously going through everything, and it's basically going to be chill, taking my time, not rushing through things, but we'll talk through the process, and we'll kind of solve these issues. Well, not issues, but we'll solve these kind of specifications in different ways. So I don't know if we want to start at the top with bet. I think we'll probably do it in alphabetical order, or actually back vesting, right? So vesting is kind of, we'll start with vesting just because it's right in front of me. So vesting is kind of simple-ish, right? Because you're just depositing some assets, and then after a certain period of time, you let someone withdraw it. And so, actually, maybe that's not the best one to start with. We'll probably do. I don't really know. I don't know. I kind of had a look through some of these the other day, and I was making some notes on them. So we'll probably start with something that's reasonably simple, just because of the time. What we got? We got auction. Auction might be an easy one to do. I'm pretty sure the version of auction is based off. Well, let's have a look at it. This one has an Aiken. I think I started making one. Yeah. Okay. So we'll do this. We'll do this because this is one that I was thinking of. Great start. So Aiken validators. Is it not just going to give it to me? Oh, it's doing the whole. It's doing the whole repo. Okay. Well, I'm just going to move around then. So auction. So this is, oh my god, there's tons on this. So the way that this works, and if we actually have a look at the specification for auction, what we need to do is we need, I can't remember what kind of this, English or Dutch, I don't really know what either of them are, to be honest with you. But basically, here's the specification. We need the seller to set a starting bid, so that's fine. We can kind of figure that out pretty easy. And then the next thing is anyone can bid if their bid exceeds the previous bid. So if we imagine someone who starts a bid, someone who starts an auction is going to set their kind of starting cost, right? Their starting fee. Sorry, I need to change this song because it's going to be winding me up otherwise. Yeah, so basically that means that you can't bid if you're bidding less than what the current bid is, the highest bid. So we need to kind of be able to allow people to bid up, and the risk here is that it says previous bidders can withdraw their funds if outbid. So the risk here, and as you can see kind of in this auction datum that exists already, the problem with this is it's only holding the highest bidder and the highest bid. So the problem is that you don't know what the history is. So there isn't an easy way to validate who is able to actually withdraw assets once you've bid. So if someone bids above you, then what happens? Like how do you prove how much you do? Right, and if you think about that in the context of like, imagine 10 people are bidding, and the starting bid's 100, and the next one's 110, and the next one's 120. How are you supposed to withdraw your 110 if you were like the first or second person? And when that scales to like 10 people, how do you know how to distribute the previous bids? A smart contract in itself doesn't look at the history of the blockchain; it just looks at the state. Right, so the state of a transaction that's being used, it can't see outside of that. And so you need to think about how we can actually allow that stuff. And if we look down here, we got our spend, bid, withdraw. Okay, so here, look, withdraw, minimal safety, forbidden, forbid arbitrary withdrawal. So you can't even withdraw, like that functionality isn't even in this smart contract. And there's nothing against the person who wrote this or anything like that, because my solution for this probably isn't going to be the best. It's just going to be a solution, right? So we want auction. Oh no, auction scholars. Mate, I should not have looked at the whole thing. Okay. Auction. Aiken. Okay. So my solution. Okay. So first, like I generally think in like complex patterns because I like the immediate solution for almost everything is a linked list, but we don't actually need to do anything like that. So what we're going to do is we're going to keep it super simple. Data is an update. Yeah, okay, so the main risk with having one UTXO or allowing all the bids to pile up is that the one UTXO is an unspendable UTXO due to the datum size, right? Because if you're recording every individual who bids, what if there's 100 bidders? It's not going to work. But what we can do is just get rid of all of this, and actually we'll just get rid of all of this. So above is simpler. So this is the alternate solution. We could just refund in the same transaction that we bid to the previous high bidder. So there's only ever one bid in the state, right, in the UTXO at any given time. And that way there's no like contesting for who's supposed to be able to withdraw. There's actually no need for previous bidders to withdraw themselves. It's part of the next bid transaction, right? Bidding higher. And I think that's quite a nice workflow for it. Auction automatically settles when the duration expires. Okay, so I'm not going to worry too much about the duration, but we'll say like there's going to be a pub type. Oh, there isn't. There's going to be an I. So we need a pub type, which is going to be our auction datum, and we'll call it because I don't want any conflicting types, we'll call it stoic auction. Okay, now I think there is actually a bit of a specification for the design for the datum. Is there? No. Okay. So I don't really need to worry too much about it, I guess. Wait, is there any in the actual Rosetta? Specifying starting bid, okay. So basically we're going to need a bid, right, and that's just going to be an int. We're going to need duration, or we can say, well, we'll call it duration from now, and that'll be an int, and actually that will just be POSIX time, right? So just be straight integer, nothing too much to worry about. The object of the auction, a string used for notarization purposes only. Okay, so like this will be the whatever. So item, we'll call it, and actually just for the sake of dealing with it, we can probably just say that it's going to be a policy. All right, it doesn't matter, just policy ID. Yeah, or it can be an asset, right? So it could be byte array, right? And then we'll just have the full asset. Yeah, I mean, we can change these things anyway. It's not like they're fixed. So we need to be bid, and then we need to be we need to put the seller, and that'll be a byte array. It'll just be a pub key hash, and then we also need the highest current buyer. I don't want it to be too long, so we'll just say buyer. Cool, and this is essentially the highest bidder hash. This is going to be ADA value. We'll just use whole number ADA. Actually, we'll just use Lovelaces, right? Be easier. And seller is the pokey hash. Okay, and then the item is policy plus asset name. We'll do them separately. So policy item. Yeah, I think that's probably gonna be fine. Policy. Okay, have perb type, and that's going to be our action. So auction action. And here we're going to start an auction. We're going to be bid. We're going to be withdraw. And was there anything else? Start, bid, withdraw, end. There you go. It's good that these have a specification. So doing this, we can basically sell any asset, right? And I guess there could be multiple. We don't really need to worry about it. We want the datum to be as lightweight as possible, right? We don't want to be messing around with like handling tons of data. It'd just be a bit of a waste, really, of space when it's unnecessary. Cool. Yeah, I mean, that's kind of it. Now, we could have, so the other one, if I remember, had like a mint and a spend. So they had a validator, stoic auction, and they had like a mint, right? So it's mint and spend. And mint is for like initializing, and we could do that because then we can identify real bids, like actual auctions, very easily, right? And because of that, we can automatically set the start of an auction. And that way, start is really just mint, right? So then we'd have a pub type mint auction. And that would be, we can just call it start for the sake of thingy, and then we can just have burn. Yeah, because then there's no conflicts. Okay, so that's probably the easiest way. Start can have all of the data that we require for this. So seller we don't need, but we can have buyer can just be an empty string. We can have bid, which will be an int. If I can type, we can have duration. We can have duration. We're probably better to have a start and an end, right? That makes more sense. And then policy and the asset don't really matter because we can just grab whatever assets we have, but actually it might be worth specifying anyway because you might accidentally try and send multiple, right? And so this, we can kind of prevent it this way. And then this will just be a start, and this will be end. Yeah, do we want to do that? I mean, I can't remember how time works in Aiken. Aiken, not fuzz. We want, what have we got here? Let's just go here. Standard library. Let's change this. Okay, time. What do we have at time? Intervals. Ability range is entirely before start bid. Yeah, okay, so does it work in POSIX time or does it work in slots? Finicky, hence workaround. Time intervals. Okay. Lower bound, interval bound, bound type. Okay. And then bound type is infinity, but is it all in? So we can have start and we can have duration. And we can have start and we can have a duration. And that way we can say, have they done it within a certain amount? And that also keeps the number smaller as well, which is like it's a minor thing to be worrying about at this point, but generally it's good to kind of do that as well. Okay, cool. We can worry about that later. We don't need to worry about it too much. Okay, so we're going to have. Do we need to set any parameters for our auction? Well, you can argue that no, we don't really need to. So we'd have our R. We have our mint auction. Yep. P is our policy ID. For our asset, not for like our auction asset, not for the assets that we're auctioning off. And then we'll have transaction. Yeah. Cool. And then we need to do like something like expect that we're only minting a single, which I think is pair singular. We'll say auction name and QTY. And the reason that we do that is because we want to be able to mint and burn, right? So we don't want to specify before we get to the redeemer types. We'll do that now. So we'll say where R is, and we'll have start, I called it, yeah, and burn. And we'll just write true for now so we don't have to think about it. We need our object here, our redeemer stuff, redeemer data. So we need tx mint, right? Yeah, so just to explain that, because I'll just start talking to myself rather than actually explaining anything. So the auction name is just the asset name that we're minting. And the quantity is going to be the amount we're using. But because it's before where R is, right, our little redeemer kind of pattern matching here, what we need to do is leave it open as a variable, and then here we say QTY equals 1, and then obviously here we'll have QTY equals -1, right? Because when we're minting, when we're burning, we're minting a negative number of that asset. It's going to be 1. So cool. Explain that. Hopefully that makes sense. And I don't have a nerd font apparently. That's a bit of a shame. So anyway, we need to go assets dot tokens here, because we're going to take the mint. You could be minting any amount of assets, right, in a transaction. So we're going to say we're going to filter our mint field in our transaction for assets of the policy ID that matches the script hash of this particular validator. So we're looking for our own assets, and then we say we're going to dict to pairs it, just because it's a nice way to handle it. So we say dict to pairs, and that way we'll get it in a list of pairs here, right? So we'll have our set as name and quantity, right? So that format, which is, again, it's a nice way to handle it. If we were expecting 2 assets, what would we do? We would have 2 objects here with a different quantity and a different, blah, 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 blah. Exactly, right? You get it. You get it. So what else do we need? So we mint our asset. We'll say our own, well, we know what our own hash is. I don't think we actually need to worry about anything else, to be honest with you. Certainly not right now. So in our mint auction start, we got bid. We have, I'm going to just work with it like this, bid. We've got start. We got duration. We have policy. And we have our, what is it called? Asset. Cool. And then this is going to be a little bit more complicated, obviously. So we might as well just wrap that now. And we're going to say, because it's not just going to be the quantity, but it's going to be several things, we're going to wrap in an and to. Cool. Just preemptively get that in place. Okay. So here, what am I doing? So here, when we actually set up our assets, so when we're actually minting, there's a couple of things we need to do. So we're obviously gonna make sure we've got our output datum, but we need to find our output first. So we're gonna say expect. We're gonna expect a single output, so we'll just call that own out. Yep. We'll just do that for simple naming conventions. And we're going to do list.filter. Now you might say, oh, we'll do list.find, and fair enough, we could do find, but find just grabs the first one. We want to make sure that there's only one. And so instead of saying find that specific output or find the first output and then seeing how many other outputs there are, we can just do it all in one by expecting a single output in a list of outputs when we filter. And we're going to filter tx.outputs, obviously, and we're going to do that with a out, and our out dot address or payment credential should equal script of our policy ID. And actually that's not the only thing, so we're going to do a little and thing here, and then we can say get this up here, tab that in. Let's just tab and backspace our way around clumsily. So the other thing that we want is we actually want to make sure this has an asset as well, right? So we'll say assets, sorry, how do we want to do this? We could do out.value, and then we can do, it's a bit more complicated because we're going to have another asset as well. We could just do like, so in an ideal world, it'll just have a single other asset, and then we can say without Lovelace, right? So you could say like assets dot without Lovelace, and that way we can just strip the Lovelace out and we'll just have a single asset, but that's not actually going to work. But we are going to do like a from. No, we're not. What we want to do is we want to say out.value, and then we want to give it one of these, and we basically want to do the same as what we're doing above, right? So we're going to say assets tokens, and we're going to wrap that. That's going to be an object, which we don't want. Okay, so we can just do it exactly the same, right? Dict.to, just so it's in a similar format, pairs equals, and then we're literally just going to put exactly the same. And yeah, I'm going to name 1. Cool. And then I'm just going to actually just sort out the cool. So, all right, sweet. And now we can say here asset auction name equals name. So now we know that these are going to match, right? And then we also know that this single output that we have is the output that contains our minted asset. All right, cool. We're probably going around this kind of a long way, but that doesn't really matter too much. So now we're going to say expect inline datum. And this is going to be our, we're just going to call it datum because we only need it as like a placeholder for now, and that's going to be our own out.datum. And then we'll expect that that is a, what's it called? Stoic auction? Yeah, so stoic auction datum. Ugh, get away, mouse. Auction. And we're going to just call it out datum. That's going to be a stoic auction type, and that's going to be datum. Cool. Change it some over. Cool. Yeah. So, all right, cool. Well, there's not really much to that now, except checking all of the datum values. All right, so we've got, what do we have for our datum values? Okay, so bio is just going to be an empty byte array. Yeah. Okay, cool. So what we need to do is we have our bid, and bid is, we're actually going to have outdatum dot bid. Oh no, that's better. And this is just going to equal bid, right? And then we're going to have outdatum dot seller equals, well, we don't actually have a seller, right? Okay, so we'll just put seller for now. A seller to do. Cool. And actually we just do that now as well because I'll forget, and then we'll get called up on it later. So outdatum buyer, and that's just buyer, and that's going to equal just nothing. And we do that because we can't really have like a variable, right? So even though it's not included here, we know that it'll just always be empty because no one's bid on it yet. And then so we need our start duration, policy, and asset. Okay, cool. So outdatum dot start, and that's going to equal. Do we need this to be a duration? No, so we'll just have start. I mean, it's got to be. Yep. Outdatum dot duration. And then outdatum dot policy equals policy, and outdatum dot asset. That is what I called it, wasn't it? Yeah. And that's going to be asset. Cool. And then really this dot has, and then we can just do tx extra sig. Yeah, because there's, I mean, and then that can just be seller. There you go. Could we do that? So we could say, we don't necessarily know that they're going to be the only ones, right? We just know that there is going to be one of them. Yeah. We don't have a seller in here. And actually, that way, we don't really need to check on it because it's going to be there. And if they haven't signed it, then obviously they're not going to be selling it, right? Actually, that's fine. So auction's fine. Okay. So we might need to do something else here in a bit, but for now, I'm quite happy with that. Burn, we're not going to worry about too much. Yeah, I'm not going to worry about that too much because it's most of it, we don't want to duplicate logic too much, right? So where here, burn, we're also always going to be spending from here because whenever we mint, what is it, 10, so if we go up here, we can go, because we know that we're always going to be minting into our own smart contract address, we don't really need to worry about that. It's kind of already there. And you know what? Okay. We could put it at the, we could put the seller at the stake address. Okay. the stake credential, but we're not going to. We're just going to leave it like this. Keep it simple. Okay, cool. So spend, we're going to need that, and that's going to be an option, and it's going to be a stoic auction, and then we'll have an R, and that'll be whatever it was called. Bid, withdraw, end. Okay, and it's an auction action. Of course it is. So we're going to do auction action, and then we're going to have a OREF, which is our output reference, and we're going to have a transaction, right? If we can spell transaction properly, which we can't. All right, and then just like the previous one, we're going to knock that in as well, right? Cool. So and we're just going to put these in. So we're going to have bid, we're going to have withdraw, and the last one was end, wasn't it? Pretty sure. Yeah. Cool. And then we'll just put true, and we'll put true, and we'll put true. Cool. So what we need here is we need our own hash. We need, we need our own input. So we need our own input to get our own hash. So we'll do we'll do it the same way, right? We'll do own in, and then we'll do list.filter, and we'll have tx.inputs. We're going to do a function on ins, and that's going to be in.output reference, and that's going to be equal to OREF. And so that's going to be our input, and actually this is just going to be list find because we don't. And then because of that, it's going to be sum because it might not find any. I think that's going to be right. Might be wrong. Find out when we try and compile it. Expect own hash. It's going to be a script own hash, and that's going to equal own in dot output dot address dot payment credential. And so now we've got that, we can say we don't really need to check that it has the asset, but we can. Well, we'll get the datum. Expect, that's going to be, oh no, we don't need to. Okay, so because it's an input datum, we kind of already know whether or not we have it, right? So we can just say expect sum d equals dat. All right, and that way we know we can just do d.bid, d.buyer, d.start, you know, and then we have all that data with us. Okay, cool. So now we need to know what our bid value is, and we don't really need to put it in the redeemer. We don't actually need anything in the redeemer because it all kind of finishes in the output, and we can just match against the values in the output. So we don't really need to worry about that. But actually, now I've thought about it, we should also check expect check we have the auction item in the UTXO. Alright, that's really important. We need to have that from the mint, really. So it's always present. And that way, the actual withdrawal and stuff is basically hands off. You don't need to like sell it to someone else, right? You can just, when the auction finishes, you can distribute the things as like the conclusion, right? Yeah. So, okay, I'll tell you what then, let's have a look what we can do with assets. Okay, cool. So here is just looking for a single, if there's a single asset, okay. And then has NFT strict is zero match. Okay. We're gonna do this. And then we're gonna check it against, oh, actually, this might be easier to do. Yeah. Okay. So we'll say expect own out dot value dot so we're going to do assets dot flatten, and we're going to do this, right? So that'll turn it all into a list, and we actually want to ignore the Lovelace value. Do we want to filter it? Well, yeah, let's just filter it. We probably don't need to because we can just ignore the first one. I don't know if it's going to like us ignoring the first one, but we'll try it, right? So we can do, actually we can just do this, and then we can do, we don't necessarily know what order it's in. Which is a shame. P asset name 1. So okay, so here the reason that I'm kind of and ahhing about this is because what if this is in the other order, right? That's the real issue. So is there like an ordered? What have we been looking at? What have we been looking at? Does reduce? Okay, flatten width. Yeah, okay, so that's similar ones. A value is always sorted. Extracted from Lovelace has an FT, has match, Lovelace of policies. Okay, let's do policies. The thing is, then we don't know that we've actually done that, right? Merge must do it ordered. We're going to assume that that does it ordered. Because there's no like ordering, easy ordering, right? Okay, well, we'll just go with it. All right, we need to think about this. That's the only thing. Is this ordered? Okay, then we can just delete this. We'll leave it like this right now. Yeah, we're not gonna stress out about it too much. We can test it, right, with the test, and we'll see what happens exactly. So we'll be able to figure it out. Cool. So bid. So when someone's bidding, they need to spend the UTXO. So we've got our own input, we got our data, and we need to make sure that the output, so expect, we want a singleton output, right? Obviously. So we're just going to do own out again, and that's going to be a list.filter, that's going to be a tx.output. We're going to work on an out, and the output dot address dot payment credential is going to equal our own hash. Script own hash. Alright, so you know then that it's going back to our address, right? So it can't leak. That's important, obviously. And that there's only one. That's also important. We're going to do an and because we're going to need it. We're not going to worry about it too much right now. Expect inline datum. And that's going to be own out dot datum. And then we're going to expect, we'll just call it out datum again. And that's going to be stoic. Oh my god. That was far too difficult. Okay. Yeah, so now we can just make sure that all the values are right? We don't need to know who the thing is, as long as we have list has tx.extra signatories, and that's buyer. Then we know that we're always outdating.buyer. Then we don't need to check, right? What we do need to do is we need to say that, actually we can probably do a lot of it just in and. Yep. And we can say, actually we'll leave that, we'll leave it here. We can say that the out value, so own out dot value equals own in, because assets dot without. Okay, so basically the reason that what we need to do, we need to make sure that we have our bid. We need to make sure the bid value is there in Lovelace, but all of the other assets are also there. And so our out value needs to be assets without Lovelace of our input value plus our bid value in Lovelace's, right? So that's kind of what I'm thinking here. So we'll say own in dot output dot value plus bid outdatum dot bid. Cool. Yeah, I hope that makes sense. because we don't necessarily know how much is on the input, and we need to make sure that the input value bid, which actually now we do that, we can, okay, this is all output, so let's do the input first. Oh no, we've got the datum. What am I even thinking of? What do we need to do? We need to get the value. We don't. Okay. Leave this. We need to find, so we don't need withdrawal. Right, that's a function that's kind of defunct in our solution. So we can say withdraw included, and we can say expect, and that's just going to be a out. We can't say outbid because that's too confusing, so we can say priv bid out. There we go. List dot filter, and we're going to do tx dot outputs, and then we're going to have a function of out. So our output needs to be to the previous bid. So we'll say if, because we don't actually know if there will be one. And I think we can just do if and else just pretty straight up. Okay, so the problem with if else is it creates a new kind of nested tree of logic, and what we don't want to do is try and put that here and then have to duplicate our little and statements. Okay. Alright, so what if we just return true in else? Alright. Do we even need an else? Maybe not. Let's just assume we don't. So we're going to D7J, and then we're going to paste that in there, and just get rid of that. Okay. It'd be kind of crazy if this just works, to be honest. So we're going to expect that there is someone who's actually putting something in, right? And from that, we're also going to assume that that we can send directly to them. So our previous out is going to be our out.address.payment credential is equal to d.buyer. And we're going to say if d.buyer is not equal to right, we can do like these kinds of, I'm pretty sure we can. I mean, we'll find out. We'll find out if we can't. I haven't done Aiken in a while, in case you haven't noticed, guys. I mean, I have, but not really that much. Okay. Let's just write for now. And this is actually going to be an and, because if we're doing one, then we should also do the other. And the other is out.value assets.Lovelace of out.value, and that's going to equal d.bid. Right? It is a bid is just the current bid. just might be the end of that. We'll have to test that. Else true. Okay, cool. Let's just focus on what we're actually doing. So we need to make sure that the start out dot equals d dot start. You know what, we'll start with, yep, equals d dot start, and we really just need to check all of our datum types. So we got start, we got own. That's not it. It's out datum, and then it's out datum dot buyer changes bid equals assets dot Lovelace of. That's going to be own out at this point. Got that here. Yep. And then what else do we have? Seller. Seller equals seller. Buyer will leave. Bid equals out values. Seller, okay. Start duration policy assets. So we've got seller, duration, policy, assets, and d dot, and d dot, and d dot, and d dot, and we got out datum dot seller, because we don't want that to change. Out datum dot duration, and then we've got out datum dot policy and out datum dot assets. Okay, and then we actually need to make sure that the transaction finality, right, the upper bound of the transaction is lower than the start plus the duration. So we need to say this is our interval stuff. Okay, let's figure out the intervals. Okay, this might be easier to do. So we'll have interval dot entirely before, and then our upper bound is going to be, it creates an interval. So we don't want to inspect. So we don't do entirely before, we do is entirely before, there you go. And then our interval is going to be, the interval is entirely before a given point. Yeah, it's going to be d dot start and d dot duration. And that should return a bool, yes. Cool. I think we're good there. There's a lot of checks, isn't there, at the end? Cool, I don't think there's anything else. So end. So we need to basically say expect that there is a pair, and it's going to be a pair of call it auction name and -1 equals tx.mint, and we're going to call this assets.tokens, and it's going to be asset tokens of own hash, right? Because it's a policy ID, which is the same as the script hash. And so we're going to dict pairs this as well to pairs. And so basically what we're saying here is we should expect that we're burning one asset. We can check that the auction name, and actually this is anything that's being minted, so we can't mint and burn at the same time as well, which saves us from having like that exploit, which is also quite nice. We change this song. Yeah. Expect some buyer out list, and this is going to be tx.outputs fn out, and we're going to how are we going to sort this out? We're going to say out.address.payment credential. Credential equals yeah, we'll do it that way. Is it buyer? Yes, it is. Okay. We can sort out the actual value of that in a second. We're going to expect we're going to say some seller out, and that's going to be also list.find, and we're going to do tx.outputs again. And it's going to be fn out. Switch layers faster if that's alright. Out.address. I mean, this is basically the same, right? Equals verification key, and this is going to be seller. Okay, and then to figure out what these values are, we're just going to negate, right? So we can negate through the asset. There's three outputs we need, right? Oh, well, there isn't. There's 2 outputs we need. So we'll say, well, we actually kind of know what it is, right? Now that I've just done that. So we're going to add this. Tab that in, and what we actually want in here then is out.value, and we're going to say assets.lovelace, and that's going to be assets dot out dot value, and that's going to equal to assets from asset. Yeah. And it's going to be policy, and it's going to be asset, and it's going to be, we're going to ignore that. Yeah. Cool. And we ignored the asset because of the min-UTXO value. Sorry, we ignored Lovelace because of the min-UTXO value. What we're going to do here is we're going to make sure that the Lovelace of our input is going to the seller. So this will be an AND situation too. And we're going to go ask, and then we'll delete the end of the line and paste it in there. And then we'll do assets dot from own-in dot output dot value. That's where that needs to be. Cool. And then I just need to tidy this up a little bit. Zero. Cool. Does that need to go in? Yeah. God, everything needs to go in. We don't really need anything else in here because we're checking that seller gets their money and it goes to the actual seller's verification key, right? So it goes to their public key. Cool. So then what's actually missing from here? Let's just write it. So make sure we're burning our auction token. We're sending our assets. We need to name that better. Okay. So one thing that really kind of gets on my nerves a little bit with Aiken is not really a big deal, but it does get on my nerves a little bit, is how that they format nesting and how they format like the line breaks with that. So for example, if we format this with like the Aiken formatter, this assets without Lovelace out value and assets dot from assets, so down to here is all going to be one line, and then policy asset and underscore will be afterwards. But that doesn't really help you understand what it is because you're looking all the way at the end of the line to be able to see what the function is, the call, and it kind of breaks the flow a bit. But when it's like laid out like this, more vertical, it makes sense where each thing is, I think. At least to me it does, right? So I'm just going to do that, not format it. It's got a buyer out, which is going to be the assets that we're selling. And we could say we need to make sure this is the right quantity as well. Make sure it's the right. And so to do that, we need to check the quantity of the input. We can just store the number in the datum as just like a number, right, that's in there, and then you can check against it. Yeah, we can do that. Okay. Alright, cool. Well, look, let's not mess around with this much more. Okay, we kind of got it, haven't we? So let's do our imports. We're going to use what have I just done? Okay. Aiken as a collection. Dict. We're going to use Aiken collection slash list. We're going to use Cardano slash assets. We're going to use Cardano slash address. And actually we're going to use types in here, and we're going to actually use some types in here. So use policy ID. We don't use the asset name, so I'm not going to worry about that too much. Let's actually make that right. And oh shit, this one as well. This kind of thing that you do. Policy ID, pairs. Okay, so we need in here we need script, and we need verification key. I think that's it, and then we can use Cardano transaction, and we're going to use transaction. Obviously, we're going to use output reference. We're going to use inline data. We're going to use, what else do we use? Inline data. I think that's it. Yeah. Okay, cool. So I think that's about it. There's probably going to be something, there always is something that you forget when you're doing these things, or at least I do. Let's write this, and then we'll go, let's get out of here. Yeah, and then ls, and we're going to cd into auction slash, what is it, on-chain slash Aiken. Yeah. Search validators slash stoic, and we'll do test.ak. Okay. And now we can actually flick back and forth without it being too much drama. And you know what, actually, now we're here, let's just get rid of this. And here we'll go, is that going to make a new window? Yeah, and then we can just zoom in a little bit. I think that's roughly the same, isn't it? Okay. Let's switch these over. So we're going to open up our test, and then, yeah. And over here we're going to sh into stoic at 12168.143. Yeah. Okay. So here we can see what is it, Cardano template. And then it's going to be slash auction slash Aiken slash on chain. Just stop there. Cardano template, there definitely is that. CD. I'm probably just spelling auction wrong, aren't I? CD on chain. CD Aiken check. Alright, let's see what we get. Just classic spelling mistake, really. Okay, cool. Stoic. And that's there, look. I'm going to go back to test. We're going to run this again. Okay, so we're missing like a bracket somewhere, basically. Okay, let's let's not worry about that too much. Actually, I am going to worry about it, so let's just find out where it is. 44. So we go SF back here, and then we'll do 44. Okay. So we got our and there, and then that should be let me zoom out of this a little bit. Sorry guys. So that's there. So what's wrong with that then? Not really sure. It's probably just because I've written where instead of when, isn't it? Mate. What is going on? When? Mate, this is it. This is like your late night brain. It's just where? We keep that between us, alright guys. So now I can zoom back in here like crazy. Can't tell what's enough now. Okay, cool. What are you doing? Well, there you go, that's why. Okay, so basically what we need to do now is we need to use our actual validator, right? So we've got Stoic, well Stoic's actually what the thing's called, and so this is going to be whatever the project's called, which we're just going to hope is auction, I guess, and we're going to do that as C, and then we're going to do a test for mint auction, and here we're going to do C, what is it called? Flip over here, ending, validate, okay, maybe it's just called Aiken. Not auction. Okay, well let's just not worry about that too much. This validator is called Stoic auction, and we're going to be minting. And so for mint, we need our mint action policy, and we need our transaction. We'll just call it policy. Will be a little bit more verbose just for the purposes of this. So we're going to need, well, we'll do let. So when we're making our tests, so we're writing out all our tests and things, we need to do like a few things to make sure we're actually covering all bases. And I generally find it like easiest not to forget anything, because I always do if I work backwards. So normally I start with let transaction, and this is going to be transaction, and then we do the placeholder first, and we can do inputs, and that's going to be something, and we're going to do outputs, and that's going to be also a list, right? Because all these things are lists. And what else do we need in here? I think it's extra signatories, yeah, so I think that's actually it. Extra signatories. Well, obviously we need the mint as well, right? Extra sigs is a list, and we'll do mint first. It doesn't matter, but we'll just call it auction value, right? And actually, I don't have the tools, right? No. Go over here, ls cd lib. We're going to cp, and we're going to cp. Can we cp recursively? Sorry. I think so. Oh no, I'm going to mess up the thingy. Okay, well it doesn't matter. We can just make. What am I doing? I'm going to go tests, tools we want, and we're just going to yank to the end. Yeah, there you go. Q. CD, ls cd. Slash auction. Clear s, and we'll do cd on chain slash Aiken lib and touch lib slash tools. Okay. Oh no. Okay, well, I mean, we'll just have to go back and get it, I guess. Tell you what, do it this way, and then we'll do one. Yank all the way, and we're going to go Cardano template auction slash on chain. Aiken, and we're going to go tools, and then I'll just paste there. Okay. That's fine. Alright, sorry about that. I'll just do it, mess around off screen so I'm not flashing around any other stuff to you. Not that anything's particularly secret or anything, but it's just saves with the flow. So now we can basically use the tools that I have. So if we actually go and we have a look, we can't. Okay, don't worry. Use tools as T. And all tools is just some test tools, right? It's not anything complicated. It's kind of stuff that I did in the Aiken course, if you saw that. But basically, we can do things like, well, let's not worry about it too much. Let's just get on with it. So we got our auction value. We got user seller in. We got auction out. And we also need, but we don't even need a seller out. Extra signatories is going to be seller. So we need a seller. That seller equal, and then we're just going to keep it simple, we're just going to use 0, 0, 0, 0. And then we're going to have a let policy, and that's going to equal, we'll do 1, 2, 3, 4. And then we're going to have let a policy. So this is the actual asset that we're auctioning, right? And that's going to be 2222. Oh, it's not going to be. And then we're going to be let a name equal. That can be 2222 as well. It doesn't matter. It can be 3333. And we actually need our auction name. Oh no. That. And that'll be cool. So our action's going to be start. And for our start, we need a bid. And we need a start. And we need a duration. And we need a policy. And we need an asset. Cool. But asset isn't actually asset. Oh no, what am I doing here? There you go. Asset isn't asset, it's going to be name. It's going to be a name. Policy is going to be a policy, because these are the assets that we're selling, right? I'm going to say let duration equal let start equal 1,000, and let duration equal 10. Start duration, we got seller. Okay, I think we might be alright for that. I would say let auction datum equal historic datum, isn't it? I think. Actually, let's just stick that underneath so it's a little bit more vertical. And in our datum, what do we need? We got seller, we got buyer. Actually, we'll just put that like this first, because that's what we're expecting when we're actually starting it off. Bid is our bid value, whatever that's going to be. Start, we have duration, we have policy. It's not policy, it's a policy. And we got a name as well. This is cool. Right. Okay, so what we're missing then, let bid equal 100, and we'll say let what else do we need? That's it. Cool. and then we say let auction value equal t dot make asset, and the asset that we're going to make name and 1, obviously. That's also going to be our minted value. Auction value, we've already called it. Let me say let, well, we don't need to worry about the first bid because the first bid doesn't really exist. And actually, is that going to affect this? No. Cool. Cool, it shouldn't, right? It shouldn't matter for the next stage because we did this, and we'll figure out whether or not we need to actually put that in pretty soon. Okay, so now we can do let seller in equals, and it's going to be t dot input, and an input contains a t dot oref, which we'll just put as and then it has a t dot output, and the output contains t dot script address. And so at the script address, like our t.script address, that helper function just returns a non-state script payment pub key hash address, right? So it's just the pub key hash that we're worried about. And so we can just pass policy there. No, it won't be policy. It'll be, because this will actually be a wallet address. And it'll be a wallet address of seller, right? Getting my inputs and outputs mixed up. So the value is going to be t dot make ADA, I think it is, and we'll just call it 10. It doesn't matter, and we'll say no datum. So I need to remember to import that too. And then we'll say let auction out t dot output, and the output will have the script address, and that's going to be policy. Actually, will be policy. The value is going to be auction value, and it's going to be inline datum of auction datum. Right, and then we don't really need anything else. So our t.output doesn't return the reference, like the reference script like placeholder. So we don't really need to worry about that. Change the track. I know you can't hear the songs, but I can. Cool. So we've got seller, we got our auction out, we got our seller in, we got our minted value. Let's just run it. Let's just run it and see what happens. Let's not even worry about that because we're going to have to nip back here. So let's just quit out of this. And we'll say Aiken check. What have I done? What have I done? Oh, I didn't write. Okay, so that needs to be doubled. And there's probably a bunch of them actually, so we'll just go. Well, I think we can just actually swap them, but I'm not going to. I'm just going to do this because I've done it. Okay, so we can't ignore that. We have to ignore everything individually. That's fine. We can do that. What is it? Let's just do it for, and then we'll just say A. Cool. What have I done? Cool. So maybe we just flip them. So we'll say okay, we'll do it this way around then. And we'll go I expect equals assets dot flatten out dot value. Yeah. Okay, and then actually because of that we need to put some kind of ADA value in our auction out. Merge. Oh, this is like a whole thing that we've done wrong actually. We need to go assets dot merge, and then we're gonna have to do put some Lovelace in, and we're gonna have to put the actual policies, right? So let's not mess around with that. Auction value, let seller asset equals t dot make asset, and that's going to be a policy, a name 1, and then we're going to have to put that t dot make ADA, and we'll just do 10, and we'll put Lovelace equal. Yeah, okay, cool, that'll do. And then hopefully we can remember what we've called them all. Assets dot merge. And then we'll do assets dot merge, and then which one did we have first? We had the auction value, didn't we? So we'll call it Lovelace. Yeah. So we basically did, if I remember, policy and asset are from the datum, so that comes third. Okay, so auction value and seller's, what do we call it? Seller asset. Okay, We could have picked more consistent names, couldn't we, guys? Let's be honest. And then it's just Lovelace. Cool. So now that should put them in the right order as well. Alright, and there we go here. We'll quit out of this and we'll just say run the check. So we got an inline datum issue in test. So where's that? 52. No comma. Okay, so we do need an else. Where is it? Where is it? Where is it? Now, this might be a problem as well. We might have to just like return or something. Comma. What was it, like 150 or something, I think. Commas, 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 commas. Okay, so it's the next one probably. It also might have been here. Not there. We don't have an and here. This dot has tx dot extra secretaries, and it's going to be done by seller. Because the seller's going to be withdrawing their money, or we also need to make sure that it's after our deadline. Okay, so we're missing a few things here. We'll just put it there, tap that in. So what is it we need? We need to make sure interval is after. Was that what it was? How did we put it? Interval is entirely before. After, I imagine that probably is what it is. Duration is going to be d dot start plus duration. Okay. Cool. Let's just do that and then let's just see what it says. Zero fields. What? Are we sure we're missing fields? I didn't think that we were. why does it say we're missing fields here? Fold, fold to pairs, so it's a self. That's weird. And then what we the reason it's weird is because we shouldn't need to, like, there shouldn't be anything missing. Like if we have like an assets, we've got a value. Tokens. So tokens gets a value and a policy ID, so we give it a value, we give it our policy ID, and it returns a dict of asset and names. Then we're just flattening it. There's obviously something else going on. Has to be. Let's just have a look, right? Auction. So this one's fine. $61. Okay, so what if we just go so the problem is we don't want to put an expect here. So we'll go here and we'll say expect a pair of a name and one equals our value. Give them that, give them a little bit of this. And then we can say assets dot token of RP, and then we can do hopefully this will be safe now, dict to pairs. Get rid of that, and then we'll just do ask, and we'll go get rid of that, and we'll actually get rid of this too. Okay, so what's given us now? 57. It's because we've got this, look. So I think it's going to be So this is a bit tough because the other thing, the already existing, we just go here. So if we say Aiken, well actually, CD validators, do they even have tests? So they don't even have tests, okay. I don't really want to do it all in one file because it's a bit messy, especially when we're having a look at the other scenarios. I mean, I already have the types in there, so it's not really the end of the world. Do they have tests in here as well? I mean, it looks like they probably do. Okay, they do. All right. Cool. We're just going to say here, and we're going to just cool. Don't really like doing this. But and then we'll just do yeah, I don't really like doing this just because it's a little bit clunky, but we can do for the sake of doing it. Okay, and then we can say use tests as T, and then we should just be able to do something like just going to leave that. And then we're actually going to RM validators stoic, what was it, test, yeah. Tools, that's fine. Aiken, and then Aiken check. That's fine. We can go here, and we're looking for, oh no, it's all one file now, isn't it? Forget about that. So what we have to, if we just go to the top, and then we say 63. It's going to be called out now because it's outside of the kind of scope of this. Um, 60 down, out. This is so frustrating. It's just like silly little things. In future, I'll be in a better place to be doing this. So that needs to be a verification key of dbuyer, right? Yeah, I'll be in a better place to be doing these because I'll just have this flow kind of figured out. And mostly because I'm working within like pre-existing stuff, and so if people have named things or whatever, I'm just adding a file in. I need to make sure that it conforms to like the same seller, okay, I'm just going to write that, and actually probably need to, nope, we've already got it. Yeah, once I have kind of the flow of working like within someone else's code base, then it'll be a lot easier to work with. I don't know, what was it, 1.14? I think. I don't really need to move, I need to just get back here. So that just needs to return, I think. Okay. What if I just leave it blank? Can we do like nothing? Or maybe it's none, or like, yeah, nothing, so it's not nothing. None. Okay, so we need a better flow for this then, basically. Yeah, because, okay. So what if instead of doing it like this, we said when we don't do it quite like that. Obviously this, or and here we'll say maybe we can just do nothing, and otherwise we can say well, hopefully we can just do this, right? I don't know if this is going to work either. No, because it doesn't like here. Look for the following patterns. So we need to just like exit. Expecting all of them to have the following type. Work with this, I reckon. We can probably just get this, and we can just double this. Alright, hopefully. Might have been looking at the wrong bloody thing with the FL statement as well. Do we need to use the previous out for anything? Okay. Okay, so what we can probably go without saying this. We can probably say like, oh, this dot filter transaction and we can just say that it's equal to 1, right? And then we can just wrap this in like a list dot length. This is a little bit janky, but we just want it to like function. To variable using that keyword. If you really wish to discard the expression, it's unused, you can sign it. Okay. Okay, so basically we need to handle this in like a slightly different way, right? That returns true no matter what. Okay. I mean, there's probably something really simple that I could just do here that I can't really just see just looking at it. So what I'm going to do is I'm just going to get rid of this, and because this is just going to like going to keep me busy for now, and I don't really need to deal with it. So what we're going to do is we're going to force a initial bid, right? So this is going to be bid, right? And that means for the start we need to actually deposit that initial value, and you can think of this like the seller's collateral for setting the auction or something. And then all we need to do is when d dot buyer is, and then we can actually do this, because here we can just expect, sorry, we don't even need to do that, we can do our if or else, right? So we can say if d dot buyer is not equal string, is equal to the empty string, then we can do that one first. Oh my god, no, I'm stuck like that. Again. And we have the close already. Right. Else. Okay. And then we can do prev out. And we can kind of just go back to what we had before. Tab that over. Tab all these over actually. Okay, so that one's for there, that one's for that. And we can actually just get rid of this. And then because we don't need previous out for anything else, we can just discard it. And then we can basically do the same here, but this is going to be a seller out. Okay, and we'll just name it differently so we know what it represents. We'll do this dot filter, and then we'll do tx dot outputs, and we'll do fn out, and then out dot address dot payment equals verification key of d dot seller, and assets dot Lovelace out value equals d dot bid. Right, so we're basically doing exactly the same process, but if there is no buyer, right, no buyer at the datum, then we can just basically it's only been initialized, it hasn't, no one's actually bid on it yet, so we can safely say that that return is going to the is going to the seller, right? Sorry, I'm just looking at this to make sure I haven't done any silly syntaxy errors, which I probably have. Let's just see if this is gonna like it, or if it's gonna tell me that there's an error. Okay, we got past that. So then what are we after? Asset. I'm pretty sure I need to import interval as well, don't I? That value is the base. Okay, so this needs to be a merge. So we need to go assets.merge. So format this a little bit better as well. And then we're going to do ask over here. Alright. And then we'll do assets dot Lovelace of. Lovelace of from Lovelace from Lovelace, I think it is. We do mean asset, and so we mean asset here as well. Interval, yes. We do. How do we import our interval to? So basically, what we need to do, if I can get back on my window, there you go. I don't know what it is. I think it'll be use Aiken / interval. I can't remember if there was anything specific from it, but we'll find out pretty soon. Okay, so what are we missing here? I thought it was just the maybe we need to put like the transaction interval or something. Do we have a little Aiken here? Aiken interval, and what was it? It was down the bottom somewhere. Okay, so we probably need to pull the interval from the transaction. And so what we're going to have to do is find validity range here. So yeah, so that's basically, we're going to have to figure out how to do that. Let's see if we go, where do we have interval? We have interval in place here. So we're going to have to do tx.validity range. And let's just get rid of this one for a sec. So validity range is an interval. Okay, cool. So that means we should probably be able to do something like this. Tx.validity range, and then do that. That's what I'm hoping. Cool. I'll pull this other one up. Okay, that needs to be plural as well. Fuck me, how many times have I done that, do you reckon? Assets, and then, okay, so we've got past the interval thing here, so that means down here we also have the same problem, right? Where we do tx dot validity range, if I can spell. And so then that should work too. And then let's see how this goes. So that's b.buyer. it's only 7. D dot. Okay, so we actually still haven't accounted for the quantity here, but I'm actually worried about that. I'd forgotten about that, to be honest. Right, so the problem is, this is supposed to be a value, but it's a function that returns a value. And that's because we don't actually have an integer and it expects it. Okay, cool. We can deal with that. So we avoided doing this before because we didn't want to kind of tie it in, but we can have a just put amount, and we'll make it an int, and so this is going to be the amount of our auctioned asset. Yep. Cool. And that means we need to also put an amount here. And that's going to be an int. And then we need an amount here. And wherever we look for that value, we need to make sure we have that as well. Our datum dot amount equals amount. Cool. So there's probably somewhere else that I'm going to have missed this. Our bid, our asset. Okay, well we can put it here. Our datum dot amount. D dot amount. D dot amount. Wait, is that right? That's the last one, isn't it? Yeah. Okay. Hopefully that's going to have fixed it, because there's no reason why, like, where assets is making an asset. Okay, cool. It's just my horrendous typing. Where was it? 86. Okay, it's up here somewhere. Okay, we know where that is roughly. Okay, what have I done here? So here, I'll sell that out. It's supposed to have the lovelace of... It's not actually what's in the out value, right? It's the bid. So it'd be d dot bid. Buyer gets the asset. Asset of lovelace should be the bid. Or we can do it that way, and then we can say here assets dot lovelace of, and it's lovelace of our own in. Is it called own in? Output dot value, I think it is, equals d dot bid. Now it should always actually equal the bid, because whenever we're depositing it, we're updating our bid to be the value that we're putting in here. So our out value, when we're updating the thing, is always the same value as our bid, and so that means this should always pass, right? This should be right, and this should be right. Both of those things should be true. So we'll give that a run anyway. We're getting there. The error, sorting our way through errors is always a nightmare, because I don't write everything. I just write it as I think instead of actually writing it correctly, and then I work on it. Yeah, I'll figure it out with the adders later. Okay, so we've got another seller problem. That's got to be like right here. Yeah. All right, and we'll see all the syntax errors with the tests as well. Well, we know what's going on there. Cool. We're running out of places where errors could be, right? They're gonna have to be down here somewhere. Okay, so this is non-exhaustive. So what other types do we have? It means I'm missing a redeemer. It's because we don't need withdraw, because we're always withdrawing. Like we're withdrawing every time we're updating the state rather than updating the bid. And mint action is missing the assets now, like the quantity. So now we're on our test, which is good. And if bid is 100, well, we're after amount here, and what is the amount? The amount is 1. Okay, so I'm just going to put 1. Oh wait, we'll do it like this because we can do some prop tests, and that way we can make it like a variable, right? Not stoic games, it's stoic auction. Okay. Get rid of that. Placeholder. Okay, so we got an error. Hopefully that's not our test. Bloody hell, we got. Of course it is. Okay, well I tell you what, let's just we're minting, so we can run here. So this is a little bit frustrating, but it's probably worth doing because we can just catch everything individually now, and it'll just tell you exactly what the problem is. It might just be like something silly like the signature. Why'd you give us oh, there's just the warnings. Okay. I thought that was an error then. Okay, cool. So outbid is not equal to bid. Why is that not equal? Our bid is our bid. How is it not? I mean, it obviously isn't, but maybe it's just the order of things. Seller by a bid in datum, bid in redeemer. Seller by a bid and bid. Okay. Bid is the first one of the datum, so the datum is probably in the wrong place. Own out, the address is going to script P. Alright, I'll tell you what then. Let's just chuck a trace in and see what it actually is. Trace, and then we do out datum dot bid. And we're expecting our bid to be, what, 10? And it's 100. Okay, well there you go, it's 100. Why is it 100? Bid, buy seller bid, because it literally says 100 there. So outdated bids 100 and bids 100. So how are they not equal? This should also be 100, right? And in fact, we should just put it as bid. And that might just fix it, because it might be reading bid as a different value, and it looks like it was, because it was reading bid from something I'm specifying as an ADA value instead of the value itself. Okay, cool. So now I can just delete that trace because you don't need it. Here. Okay. So basically we can create our auction now, right? We're in a position where that's working. Let me get this, sounds annoying. Okay. So now, what we need to do which, what's the time actually? Okay, it's like 2 a.m. So we need a couple more tests. We need a test for bidding. What have I called it? Bid auction. And we'll just return true for now. Then we need a test for end. And again, we'll just run true for now. And then we need a test for burn. Now burn should also happen when we end, so we shouldn't really need to test it like individually, uniquely, if you know what I mean. So actually we'll leave that, and then we can have a what else do we need to do? We can have a test for bid 2. Right, so that we're updating a point, right? That's kind of what I'm thinking here. And then we'll also need a test that fails. So we need a mint. No, we don't really need a mint fail. What we'll do, we need a mint fail, and we'll say mint error. Mint. The thing is, there is lots of reasons why it could fail. So what we don't really want to do is just have a random thing fail for no reason, right? And then this will be false. And then we want a test, we want a bid to fail. And we're not going to just... It'd be really nice if I could actually type this evening, because it'd make things so much easier for everyone. We also want to test, so we got a mint fail, and the mints can fail for whatever reason. Like I think the main reason is asset mismatch. We can have a datum error, I guess. It won't be that, it would be, well, the asset mismatch is the obvious one. Bid auction can be bid no withdrawal. So test, and that's almost like having like a double spend, right? So instead of you trying to like withdraw twice from an asset or try and spend a UseCase twice, you're trying to like send that asset back into the bid, so you're just updating a bid rather than supplying the full amount for a bid. You can have a test where you say withdraw assets. And this is quite a big one because you shouldn't be able to, basically you shouldn't be able to withdraw the assets. Try to remove auctioned value without paying. Right? Or before the bid ends, auction ends. And obviously this should always fail too. Yeah, and then test end auction fail. And this I mean, why would the end auction fail? We could have not pay seller. not pay bidder, buyer, because that's how it's named. We can have not burn asset, or we can have too early, right? It could be like any of those things. Either way, we'll just leave it false for now. It might be worth doing all of them as separate tests, and then I'm not going to do property-based tests for this one actually, because we can take so basically I don't want to do property-based tests for this because it's taken ages to just get through the first start of it. But I think like tomorrow or like the next stream when I do the next one, because this is one of 20 odd, if you remember. So we got anonymous data, atomic transactions, we got bet, crowdfund, DIDs, editable FTs, escrow factory, hashed something, lottery payment splitter, price bet. We've got the simple transfer, simple wallet, storage, token transfer, upgradable proxy, vault, testing, and there's another one that I think isn't in here, which is the AMM. Oh no, constant product AMM is there. So like there's 20 others. There's going to be plenty of times to do prop tests, and what I'll probably do is in one that I just smash through, because as I get more in the flow of just dealing with it, doing the streams, it'll be a lot easier to get things done. Then we can start looking at the prop tests, because even though the prop tests aren't complicated, they're complicated enough that they're an extra step on top of just like unit tests, right? Because you need to set them, and you're not really going to get benchmarks out of it in the same way that you do here, right? You obviously get like a lot of a benchmark out of this, you get lots of information, and what we want is with our prop test, we're just going to get fail, and we're going to get what it fails on here. So that's the only data, not the amount of not the cost associated with running that transaction. So yeah, cool. All right, I'm going to fix these up as well, and I basically have this set as a fork. So what I'll do is for each of these, when I get these tests finished, I'll just create a pull request to the Cardano Foundation's main GitHub repo, and then I'll just keep working in that. So I'll just have a pull request for each of these rather than bundling them all together, because there'll be a lot to review otherwise. So yeah, cool. All right, guys, if you showed up, you had a little look at this, or if you see it in the future, thanks. Sorry, I know it's a bit slow. It's like 2 in the morning for me, so it's been one of those days where I'm just like ready for bed, basically. But it's the first video I've done in like 3 years, I think, or something like that, on for Stoic, and so we're going to be doing a lot more of these, because I have a bit of time available to do more of this stuff now. I haven't in the last couple of years, so going forward, I kind of just want to build a bunch of open source contracts and kind of think about tools that we can build for Cardano that we can help kind of push the ecosystem forward. So I'm just going to be working, kind of doing live streams to do that most of the time, I think. But yeah, I'll catch up with you in the next one, guys. See you then.